working. Right, so the idea of this is that we all have this, how do you call it, this application that we all know about, that is called the web browser. I think everybody's familiar here with the web browser. We all use one, and arguably the, see, this is what I like about the Mac. Now it's showing me the slide control on the wrong screen, so I'll just go back to mirroring. I absolutely adore this. You'd think they make it easier. So we're going to use a web browser to just do a small demo about what are the risks associated with not having your secure DNS. The real problem here is that, okay, we all use a web browser for most of, I would say, if not all of our internet use. A lot of people assume nowadays when you say the internet, you actually mean a web browser. And probably for some of the younger generation, when we say the internet, they understand Facebook. Somebody was mentioning this. We were in Cambodia last week, and somebody was pointing out that there was maybe 500,000 users in Cambodia, and of those there was maybe 499,000 Cambodian users on Facebook. So that pretty much dictated where people were going. We also use the browser for other applications. We use it for net banking. We use it for e-government. I live in Denmark. I'm French, but in Denmark we have a lot of what we call the e-government. I can do my taxes online. I can order a new license plate for my car online. I can do pretty much anything, including buy my house when I have to do the digital signature for the deed. That happens online. So you imagine there's a number of applications here where it's rather critical that we're certain we're talking to the right machines, the right servers, and that those services can ascertain you're the right person. I don't want to hear later that some random hacker from some other part of the world or in the same country has accessed my bank account and emptied it because they were able to spoof my identity. So we'll just walk through a quick demonstration that'll try to highlight some of the risks that there are with having non-secure DNS as it applies to web browsing. Now, this is just one of the applications that we're using every day, and we'll get back to this at the end of the demo because, again, the web is not the only application on the internet. It just happens to be the one that attracts the most attention and is the one that is the most visible, but by far it is not the most, dominant protocol in terms of traffic. So we'll just use the web browser. We'll show how users can be affected by this kind of attack. So I'm going to run this as I talk interactively, and I expect you that if it doesn't look clear or you have a question, just raise your hand, say I didn't understand what happened here, or what is the purpose of this you're doing. So I might run some commands on the side. I don't expect you to follow. I'll explain what it is that you're supposed to keep your eyes on. So here's a simple example. If I take a web browser, and here there's absolutely nothing special about it, I'm running on the wireless, and I'm going to really take this improvised. We're running on the Cyberport Open Wi-Fi. Okay? I just have to disclaimer, I am not trying to blame what I'm about to do on the Cyberport Wi-Fi. This is not the fault of any ISP. The problem here lies not in the particular ISP. I just happen to be here, right? So I'm using the Cyberport Open Wi-Fi, and as far as I'm concerned, if I use, let me just see here. If I use the terminal application, I don't know why it's not in my history, but never mind. You'll see why I do this. So I have a little terminal, which I'm going to make big enough that you can actually see what I'm typing. Okay. Do you need to understand what I'm doing here? No. The only thing I want to show you is you're running a laptop. How many of you know what DHCP is? You plug in your laptop, it just works. And if you don't know what it is, well, that's what makes it possible. You can plug in your laptop, put a cable, it just works. Right. Now, so if we look at the, here already I can already show you that my setup is non-standard because I can't see, now I can't see the icon for Unbound. I can show you that my laptop is currently running its own name server. I'm actually ignoring the, the name server that's being provided by the Cyberport because I have my own DNSSEC validator on my laptop. Already this is not common. So what if I were just a plain laptop from a normal user and not a geek like me? The first thing I would do would be to turn off DNSSEC validation. And the only way I can do this is to unplug this because otherwise my screen is not wide enough to see the icon. That's one of the shortcomings of the Mac. There we go. Good. So now what I've done is I've reverted back to plain old laptop configuration. Some of you may have a smartphone. You turn it on, you get a name server, a DNS, given out by the Cyberport Wi-Fi. And now I can see I'm using something called 202.83.240.66, just some random IP address. How do I know it's working? I can say ping www.yahoo.com, and I am getting an answer from yahoo.com. So far, nothing special. Now, if I go over here and I try to browse, I say, I don't know, I want to go to my gmail.com. Okay. It loads my gmail.com. I didn't even have to log in. Okay. So I'll log out, sign out, and I'll log in again. I've created a user for this show today. I call it my last name test, and I give a password which I'm not going to tell you about for now. And you can see here, what do we notice? We notice that there's an HTTPS, right? There's a little HTTPS icon telling me I'm using a secure connection. Everybody knows about this, right? That's what tells us that there's not an evil person sniffing my passwords or sending them out and selling them to somebody. Can I also go on Facebook, for example? Yep, that looks right. So let's log out before anything improper appears. I don't know what people, I get tagged in pictures sometimes. I'm like, that was not me. So here I am. I'm logged into my test account. And here again, Facebook, again, is using the little icon. Can I choose to actually run Facebook non-secure? I don't think you can anymore, right? I can, but I have to go in my settings and turn it off, right? So you assume it's okay. What happens if I now connect to my home server? Oh, certificate is not trusted. Why? Because I'm stingy and I don't like to pay certificates. So I made my own. I signed it myself. But what happens is my web browser does not know who issued the certificate. Everybody is familiar how SSL works? Rick explained it. You buy a certificate. You pay somebody who ascertains your identity. They do it to a certain degree. You can get one for $5 or $0, like sponsors or adverts or whatever. But the idea is that the more money you pay, the more they're willing to guarantee. If you ever have insurance for your home, the more money you pay, the more they'll pay you back if you have a break-in. But if you say, I want a $1 million insurance, US dollars in my apartment, they're going to say, what kind of locks do you have? And are we certain that you actually do take proper measures to lock your house at night or your business? Same thing with the SSL folks. If I'm going to have PCI certification, the payment certification, they're going to actually send people over to physically look at my infrastructure and say, well, it looks like you're doing things reasonably. Therefore, we're willing to guarantee up to, I don't know, $100 million in damages if you do get hacked through the SSL certificate. All right, only that particular part. So it doesn't guarantee that some employee is annoyed and runs away with the keys and then gives it to somebody else. So it's a particular specific case for which you're covered. So in this case, I don't care about guarantees. I just want to have SSL, right? And remember, we say SSL certificates. They're actually called X509, but nobody cares about that. We don't. Honestly, do I care about who made the certificate, or do I care about the encryption? As an end user, I kind of care about the encryption. But of course, there's the other aspect, which is the trusted issuer. If Thought or VeriSign, who's not in the certificate business anymore, but one of the big companies says, yes, this is your bank you're talking to, I kind of trust them. I trust them because they're staking their reputation on it and they're staking their business model on it. So somewhere I'm thinking these people don't want to lose money, so I have to assume they're doing the right thing, and therefore when I connect to my bank's website, I don't want to see this, right? Let's go to my bank. I'm not going to log in. Anyway, it's a one-time token, so. And what happens, I get automatically redirected to a secure sign-in page. Actually, here we are. It's in Danish. Don't worry. I'm not going to expect you to read it. But I'm redirected to HTTPS, and so far everything is good. Okay. So what happens if the DNS is not secured and I have SSL? Somewhere, some of you must be thinking, I hope you are, well, isn't it good enough to have SSL? Secure Sockets Layer. Well, here's the problem. The first problem here is that not every protocol on the internet is about the web. The second problem, here I am, I can log in. And you can sniff all you want on this one because I can even type my password if I wasn't a little bit paranoid. It's going to say, hey, now it's time to pull out. Well, I cannot type today. It's like, fine, pull out your one-time token and type in the key that's timed. So, okay, you can't do anything there. They're smart. But let's assume now I'm just logging into my Facebook. And I've had this discussion many times with Rick, with Hervey. You know, as an individual private person, as a business owner, yes, I'm worried about somebody breaking into my net bank. But how many of you here have a Facebook profile? How many? Okay. How many of you care about, how many of you are worried about somebody taking over your account? I'm not saying about how likely it is. I'm saying, do you care if somebody takes over your account, as in, oh, somebody posted some fake pictures of me or pretended I'm a criminal or a crook? Would it bother you or would it not bother you? It would bother me, because I have a lot of people that I talk to, and maybe they don't know me very well, and they know that if somebody writes, oh, Philip is a thief and he's a liar, then I'll be very worried, because a lot of people who don't know me very well suddenly have this image of me that's been projected. It's identity theft. It's reputation. So I do care about the encryption as much as I care about the monetary aspect. I really do care that I'm really talking to the right Facebook, and I really hope that somebody's not sniffing my password. Because if they are, that means that they can go and impersonate me. And in today's digital world, your Facebook profile, your Flickr account, your Twitter account can reflect very badly. It only takes one bad tweet, usually a legitimate one, to ruin somebody's career. So imagine if somebody accessed your account and said, haha, whatever, I'm not even going to come up with examples, and criticizes somebody publicly. It's very difficult for people to backtrack and erase that. So digital identity and in 21st century and theft of digital identity is something that people do worry about. And me as an end user, I'm not a political person, I do care. Because I have a lot of people, if they read this stuff, they'll believe it, or even if they don't believe it, it'll still leave a mark. Like he probably didn't use a good password. And he pretends he's a security guy, you know? Or what did he do? Did he leave his laptop open? Or all kinds of things can be assumed, right? The safe thing to do would be, as Rick said, don't have a Facebook account, right, Rick? So what I'm trying to say here, and I'm getting to the real interesting part, is we assume that the SSL is protecting us, and when there is no SSL, we get told. And this is one key thing I'm going to repeat. When we have SSL encryption, we are told. Are we told when we go to a website and there is no encryption? Okay, I go to CNN.com. CNN.com does not show an SSL logo. It does not show anything. Okay, I don't expect a news site to be SSL encrypted. Why should it? Okay, and then let's say I'll go to the ISOC. Okay, so ISOC.org. Okay, fine, no problem. It's here. I'm looking at it. It's not SSL encrypted. But when I go to my Gmail and my Facebook, there is a certificate. How many of you look at that certificate? What if I go to Amazon.com? Right? Amazon.com, I can browse on it. I could look for books. I don't know. Let's look for SSL. Let's see if there's any good books on SSL. Okay, here it is. All right, 2,500 watt dual 12-inch speakers. No, that's probably not the right thing I'm looking for. But then I actually do want to sign in. You know, I sign in here, and it's like, oh, okay, HTTPS comes on. But when was I asked, when was I warned, you are about to go on an SSL page? There's a browser that does that, Firefox and Explorer. And what do you say? You say, do not warn me next time, because we don't want to be told every time we go on a web page that's got SSL, do we? So we sign in. And now I can go and buy stuff. It says, hello, Phil. So it looks good. So, okay, I don't really care about this. Sign out. Most people never sign out. Neither do I. Anyway, okay, so far so good, right? Nothing special. So here's what happened. We're going to play with a little tool called SSL strip. And what this tool is going to do is take attempts to talk to an HTTPS server, and it's going to refuse it. And it's going to redirect me to a website that doesn't have SSL. So how this works, and of course I'll try and do it in a quick fashion. I'm going to first pretend that I'm not using the DNS resolver that's provided to me by the cyberport. I'm going to use one I've set up. And the whole problem with DNS today is that you have to trust the ISP you're talking to, right? And you think, well, I have SSL, I have my certificates, right? Let's see the certificates we're talking about. This is all the certificates I have in my Mac that are trusted. There's 182 different certificate authorities I trust. In reality, there's 1,500 people I trust, companies I trust, because these guys sell certificates to other companies who sell certificates to us, right? It's called third-level certificates. So these guys, I have to all trust them, which means that when I connect to my SSL website, I have to assume that these guys are all running, you know, top-notch security and haven't been hacked. Okay? So that's a lot of trust, right? As Rick was saying, you know, how can that be exploited? And there have been issues. So I'm fairly sure that nobody's messing with the SSL. Well, I don't even need to mess with your SSL. Here's what I can do. I'm going to modify my DNS, and I'm going to say I am actually not running on the cyberport anymore. Let's say I unplug and I'm connecting to some other ISP. Let's say I'm sitting on one of my friend's home networks. And instead of using the name server that is provided, these two name servers here, I'm going to say I'm going to use this just home name server called 10.10.0.66. Just happens to be another DNS server. Every time you move your laptop or your smartphone from one network to the other, you get a new IP address, you get a new DNS server, and that happens all the time, right? I move on 3G, I get one DNS, I move to the wireless, I get another DNS. It happens constantly. So I apply. Is this the case? Can I resolve? Oh, no, it actually doesn't work. That's typical. Oh, because I'm, all right, okay. Yeah, it's, that's the user interface error. That's not my problem. All right. Let's try again. Yes. So does it work? Can I say ping? Well, I'm going to use a tool called dig, which is kind of, geek tool for DNS, but I want to make sure that I can resolve my own home directory, my own home server. Yes, it works. Okay. Now here's the problem. DNS can be poisoned, or could be. It could. It's actually very difficult even without DNSSEC today, because in light of the Dan Kaminsky, security researcher who in 2008 very conveniently found severe security holes in the DNS, after the mitigation, the patches were deployed to fix most DNS software, it's still quite difficult to do cache poisoning. But you don't have to poison the cache. You could be sitting on a network in a Starbucks, and you think you're talking to the Starbucks Wi-Fi, but the guy next to you has got one of those pocket MiFi and pretends to have an SSID of Starbucks. Or you could be in a train station or in the train, and you connect to that SSID. You don't know. Or you just simply have an ISP you can't trust. Do anybody remember DNS redirections you would some years ago? Or even you're sitting in a hotel. You connect to the internet, you type google.com. Do you go to Google? No, you go to a page that says please log in and pay. So somebody's already messing with the DNS at that point, correct? Because you think you're talking to Google, but the reality is you're actually talking to another. All right? So what happens now? I've kind of cheated. If you look here, I'm going to ask for facebook.com. Uh-oh. That doesn't look like a real IP address for Facebook, does it? Because if I ask the guys at Google 8888 to facebook.com, it tells me this is the IP addresses for facebook.com, right? That's all of them. So how come this guy 1066 is giving me, that's my name server. For those of you who are not DNS savvy, I have a machine that's lying to me. Okay, so I'm going to be redirected to Facebook. But I don't care, I have SSL, right? So when it's going to come up and present to me a fake certificate, it's going to go, ho, somebody's pretending to be facebook.com. Don't log in there. Whoa. I was like, oh, okay, I'm safe. I'm safe. Okay, so let's try it. I'm going to try that. I'm going to go to my terminal. I'm going to flush my DNS, as we call it. And I've cleared my browser. I'm going to clear the cache. I'm going to make sure I have nothing in there. Start fresh, because computers like to remember things. And we're going to go to facebook.com. And it might work. It might work. This is where the live demo part where Rick says I'm very brave. Right, actually, I just have to keep an eye on what's happening here. Obviously, somebody's doing this in the background normally. You're not seeing this live. Okay, it's not. Let's try again. Sorry about that. Just a second. I should be running now. Let's try again. That's typical. Of course, when I do a live demo. This worked, of course, while Rick was talking. So just give me a minute here. That's what happens when you reconfigure your network all the time. Yeah, exactly. Well, the JavaScript part gets a little bit difficult. 2 seconds here. Oh. That's the problem. It's not using the right name server, so it's going into a loop. There we go. Okay, I'm logging into Facebook. Sorry about that. This is not looking good. All right, Amazon. Sign in. Yeah, this is looking dodgy. Unfortunately, this is not exactly how it should look like. So already you would be suspicious. It's a very nice security program by a security researcher that does this. The problem is already most of you would realize something is wrong at this point, right? So there we go. So much for saying that the live demos are trivial to do with this kind of software. It's kind of annoying, actually. Oh, it really doesn't want me to. That's interesting. Well, it worked perfectly an hour ago, but you know how that goes when you do live demos. Well, I emptied the cache, so I think that no. Oh well, we can do one last attempt with gmail.com. That's interesting. See, it has cached it. There's something wrong there. Not available. Yes, that's the whole point. Clear the cache. Yeah. It is not giving me, it is giving me a hard time. So let's try another web browser. All right. Okay, so I log into my, now here's where the picture is wrong, apart from the fact that the pictures are wrong. Here's the problem. Do you see an SSL icon? Okay. So here's the first problem. Now, sorry about the glitches on the other one. I'll have to test it. I'm going to try it, of course, with my Facebook over here. So it's filling out the login. There's something wrong with the images. I don't know what's happening. But I'm logging in. The problem is here that it's actually denying any attempt to connect to SSL. As I'm making a connection to the non-encrypted website for Facebook or Gmail, as the URLs come back in the source code, meaning please reconnect to an SSL site. What's an SSL site called? HTTPS. It blocks those. And it says, no. Keep going to Facebook.com. Because I've already, as an attacker, I've already succeeded in poisoning the DNS for Facebook.com, forcing it to a particular machine. So I completely bypass you talking to a secure server. I force you to not talk to a secure server. Apart from the fact that it looks a little bit strange right now because of some connection or cache errors, there's no SSL. So what happens if I log in? Will it work? Or will it say, no, you're not secure? Okay. I'm a little bit paranoid, so I only allow on a need-to-know basis. It says I don't have the right password. That's because I changed my password. So let's try this. Let's try my test account here. No, that's typical, yeah. Oh, because it's not. Oh, okay. So that's different than what was happening in the hotel. Now it knows I'm in Hong Kong, so it's redirecting me to the Hong Kong page. So all kinds of things are happening to make it difficult for me. Yeah, there you go. The wisdom of Rick was absolutely correct. It's going to be more difficult. Yeah. But what's happened at that point is I've logged in, and if we look here, I wonder if it actually crypt the log. See here? I don't know how many of you can read this, but it says my password attempt was ABCD1234. So at this point, I'm trying to log into a web service. It's blocking my access to the SSL site. I don't know as an end user, I mean, if this is my mom using Facebook, she'll never check that they never actually allow an SSL connection. Now I have another error here of another nature, but the main problem is I'm trying to log into Facebook. At nowhere do I see an SSL connection. Yeah, it can't loop. I don't know, for some reason it's trying to generate the pictures. It's not working. So it's denying me SSL. So I bypass the entire secure sockets layer. I bypass the certificates. Okay, and you have to believe me, unfortunately I don't have a screenshot here, but an hour ago I was getting a full picture and I was logged into Facebook and I was surfing. And if I go into Amazon.com, it would be the same thing. I would be able to browse, but as soon as I went to my account, which will not load here because of a problem with the cache, I don't know what it is, it will simply allow me to type in my password, and at no point will I have SSL enabled. I'll have the little Amazon icon, but do you see SSL there? No, you don't. So how does SSL help us when we can actually do this kind of attack and the end users get fooled? And hopefully by the time we go into the panel, I'll have this working. I can do the demo again. Then we actually cannot trust the server. So how do we trust the server? We have to turn on DNSSEC. Because if we turned on DNSSEC, what would DNSSEC tell us? DNSSEC would tell us that this is absolutely false. This is wrong. How can I trust this? Well, in the traditional DNS, I don't have a choice. I have to go there. And I have to hope there's an SSL connection at the other end. Right? But I go to the server 10.10.0.66. Every time that server receives a request, what does it do? It turns around, connects to the real Facebook, connects to the real Gmail, and it returns the link, rewrites the SSL, turns it off, and I, as an end user, I never notice that. I simply never pay attention. So what do I have to do to turn on DNSSEC? I will simply turn on validation. That's all it takes as an ISP to validate. It doesn't mean that suddenly everybody on the internet uses DNSSEC. It means that those who have deployed DNSSEC, suddenly you will be able to verify their claims. Facebook is not one of them. Gmail is not one of them. Amazon is not one of them. That's interesting, isn't it? So those big companies have deployed IPv6, but they haven't deployed DNSSEC yet. They're working on it. We know that. They're just afraid. I guess they're afraid of the same things I'm afraid of, that things stop working when they're trying to show it to the public. So I do this, and then let's see here. Restart my DNS. And now what happens is if I do this and I dig facebook.com, it's going to still give me the right one. Now, how do I know that it's protecting? Let's try something like isoc.org. isoc.org is DNS. Oh, server failure. Something's wrong. Why? Because actually, if I didn't have DNSSEC, it would tell me, hey, isoc.org is 10.10.0.66. But when I enabled DNSSEC, what happens when I go to my web browser? Now, isoc doesn't sell anything, doesn't have online shopping, so it's not as critical. But this is what I get as an end user. Is it better to tell the user, here's the fake website, and fool them, or is it better to stop them like this? Well, I would rather have this as an end user and have them call the ISP and say, I got a problem. And then, I can do the tech support and say, well, what's the issue? And say, I can't go to isoc.org. And I say, oh, somebody's messing with you. So I've blocked the user, and of course, this is the early stages of DNSSEC. What we really want is to be able to tell the user, watch out. This website is insecure, or this website has not been signed. And how do we do this? Well, in that particular case, all I have to do is revert. One of the last things I'm going to show. I'm going to revert back to my normal DNS. I'm going to stop using my rogue pirate DNS. And I'm going to take it off and go back to what the cyberport was allocating me, which I can trust, apparently. I don't know that. And then flush my cache. Hey, here it is. Now let's try with Chrome. Okay, cool. It's working now. So when I go back to my non-pirate DNS, it works. Now the question is, can I actually show that DNSSEC is working? I do have a DNSSEC validator, don't I, in here somewhere? Yes. It says it's enabled, which it doesn't seem to actually be doing. That is correct. It's probably not validating on the... Oh, it was earlier. Well, you know how it is. Earlier, it was working with the cyber port. So, another case. You think so? but it normally just shows up. There is no validator icon. So it's kind of interesting, isn't it? Yeah. All right. Well, probably one last attempt, and then I guess we'll have to turn it over. Yeah, so it worked when I was sitting down. It doesn't work now. So the validator on the, yeah, I have no idea what it's. It's kind of funny, isn't it? So the one thing I can do, will be my last reprobe, force DNSSEC on my laptop. That's much better. Yeah. So now I'm running a DNSSEC enable validator. I get a little icon there on my Chrome telling me, hey, this domain is secured by DNSSEC. And if I do that, it doesn't matter if I redirect the person to another server, or I try to by hijacking the ISP or poisoning the ISP's DNS, my browser itself is going to say, no way, I can't. Why? Because the chain of trust in my browser is going to say, okay, the root was signed, or rather, let's go the other way around. ISOC.org or InternetSociety.org was signed by the Internet Society, and they had the org people sign it, and they had the root people sign it, and the key for signing that, I have it in my laptop. So it doesn't matter if somebody's hijacking in the middle, I'll detect it. Right? Now, you're probably thinking, how is one key from the ICANN ICANN/VeriSign/community, it's also the community, is more trustworthy than 1,500 certificates? Well, the whole idea is that you have an audit process which is actually much more transparent. You have one group of people you have to trust, plus, of course, the various registrars. I mean, if you cannot trust .hk or .org to do the right thing with DNSSEC, you can't trust anybody. Then you shouldn't buy a domain in there. And this is all where the choice is an end user. You can choose to buy a domain in various TLDs, hopefully HK, and say, well, if this is signed, that's okay, I can trust it. And then I have to trust the people of the ICANN root, and this is a transparent process. On the other hand, an SSL certificate is going to be one of 1,500 companies. So you can't necessarily trust those. All right, so that was as much demo as I'll be able to do without confusing more of you. Nobody fell asleep, but I can imagine it's just about time for the break. So any questions? Yeah? The validation you see here is fairly new, but it's actually, this is just a plugin that goes and does an extra check, talks to the DNS and says, yes, by the way, this domain is signed. The next step, and to answer your question, Firefox can have it, Chrome can have it, Internet Explorer not yet, but the next step will be to go a little bit further, which is to use SSL certificates and sign them with DNSSEC. So you'll have two security layers. So yes, it does depend on the version of the software you're running, and it's not active by default, but again, we're only 2 years into signing the root. This is something that, as Rick pointed out, took 20 years to get DNSSEC designed. It actually started in the early 90s, and it's moving very fast now. Okay, because, oh yeah, that's the last thing I, of course, wanted to tell you from my presentation. There is, this demo only is about the browser. What about email? What about chat? What about IP telephony and file transfers? Your email server, if I can spoof the DNS, I can hijack your mail, receive it, read it, and then forward it to the proper recipient, unless you're encrypting it. I can. Of course, I can't just do it. I have to attack you. With DNS security, that becomes pretty much impossible, because the moment that the mail server is told, deliver this to 10.10.066, they're going to go, no way. That's not the right IP, because, you know, ICANN says it's not, or NSRC says it's not if you're trying to send a mail to ICANN or NSRC. They claim it's not that IP address. I'm sorry, I don't believe you. Stop here. So suddenly you have security end-to-end on all the data. Yep. That's it, I guess. All right.